For our notes today, we're going to take a look at solving linear systems by graphing. So in the warm-up, we're just going to review how to graph lines in slope-intercept form. The first one is already in slope-intercept form, where 1/5 is the slope, the y-intercept is 4. Where number 2, we're going to have to rearrange and solve for y before we graph it. So at this point, I want you to pause the video, try the warm-up, and then resume the video to check your work. All right, let's go ahead and check our work together. So like I said, number 1 is already set up and ready for us to graph, where y-intercept is going to be a +4. So that +4 is where I start my graph. My slope then is 1/5. So I'm going to go up 1 and right 5 and plot a point. And once I run out of room, I'm going to go down 1 and left 5 and plot a point. I'm going to connect those dots, throw some arrows onto the end, and I'm good to go. For the second one, we have a little bit of rearranging to do. So I need to get y by itself by subtracting x on both sides. So I'm left with 2y equals -x plus 2, and then I divide every single term by 2, where y is going to be equal to -1/2 x, and I'm going to add that actual -1 so I can see that that's the rise, then x plus 1. So y-intercept is a +1. Slope is -1/2. So I'm going to go down 1, right 2, plot a point, down 1, right 2, and keep going till I run out of room. And then when I do so, I'm going to go up 1, left 2, and keep going, do the same thing. Connect all my dots, throw some arrows on the end, and I'm good to go. All right, so at this point, you should be following along in the notes, graphing them with me, and then after you go through all 3 graphs on the notes page, you're going to flip it over to the back. The back side will be practice homework for us to finish in class. Anything that you don't finish will be homework. So I like to draw these with 2 different colors. You're welcome to do so if you want. Our ultimate goal is to graph both lines and then see the point where they intersect. That point is a solution telling us just what I said, where those 2 points intersect. So I'm going to graph this top line in red. It's already in slope-intercept form, so we're going to plot our y-intercept. Our slope is -2. I have no room to go down on this graph, so I can't go down to right 1. Instead, I'm going to go up 2, left 1, and I'm going to keep going until I run out of room. On these graphs in particular, we want to graph them as accurately as we can because it's really going to help us see what our solution is. So I'm using my line tool. You're welcome to use some sort of straight edge to help you draw your line super accurate. I'm going to then graph the bottom line. My y-intercept is 3. My slope is 5/1. So even that -2, I made it over 1. That's my rise over run. So I'm going to go down 5, left 1. That's as many points as I can graph. But lucky for me, I already see that solution. I see the point where they intersect. So once I connect those, I'm going to throw my arrows back on the end. My answer to the question is not the graphs, though. My answer is the point where they intersect. So I would say the solution is -1, -2. So our entire goal today is to graph 2 lines and look for the point where they intersect. Moving on to question 2, we're doing the same thing. We're graphing those 2 lines, seeing where they intersect. So again, I'm going to start with red. My y-intercept is -3. My slope is 1/2. So I'm going to go up 1, right 2, up 1, right 2. And when I run out of room, I'm going to go down 1 and left 2, down 1 and left 2. I'm going to use my line tool to make a nice straight line. And let me draw that in red. I'll go ahead and throw some arrows on the end, and then we'll move on to the second line. So second line, I'm going to graph in green. My y-intercept is 4. Slope is 1/2. So again, up 1, right 2. I ran out of room, so I'm going to go down 1, left 2, down 1, left 2. Using my line tool to connect all those dots, throw some arrows on the end. I should notice these 2 lines are parallel. So if I have parallel lines, they never intersect. So if I have 2 lines that I graph that never intersect, this is no solution. Those two lines will never touch. They will run the same distance away from each other, but never touch. Now, I could tell this because I graphed it and I see that those lines are parallel. I could also tell we have a no solution case when we have the same slope. So I notice my slope, positive 1/2, positive 1/2, but then a different y-intercept. My y-intercepts were -3 and +4. So if I have same slope, different y-intercept, that would be a no solution case. We prove it by graphing, but I can also tell from the equations. And finally, moving on to our last example. So we saw a one solution case. We saw a no solution case. This is going to be our infinitely many solutions case, but we have to prove that it is so. So if I take a look at this top equation, I notice I have to get it equal to y. Now the y right now is on the right side. I'm going to keep it there, but move the 4 over to the left. So I'm left with -2x minus 4 equals 2y. I'm then going to divide every single term by 2 to get my line and slope intercept form. At this point, if I'm more comfortable writing this y first, you're welcome to do so. Our slope is -1. Our y-intercept is -2. So y-intercept is what we graph first. I go down 1, right 1. Our slope is -1/1. I'm going to plot all those points till I run out of room. I'm going to use my line tool to draw a nice straight line. And then we'll put some arrows onto the ends. We have to do the same thing with the bottom equation. You're welcome to move things in any order. I notice that if I just add y on both sides, the y is already by itself. If I feel more comfortable than rewriting my function with the y first, I'm going to want to reorganize my left side to be -x minus 2. Now I can already kind of see what's going to happen here. But again, I have y-intercept of -2, slope of -1, which is down 1, right 1. And I can see that I'm plotting points in the same exact spot that I plotted all the other points. And when I draw my line on top, I can see that those two lines are the same. So if I graph two lines directly on top of one another, that would mean I have infinitely, let me spell it correctly, INF, infinitely many, there's an E there. Hopefully I spelled that right. Infinitely many solutions. Most of the time, you're going to see me write this as IMS. We're going to abbreviate. Now, on our no solution case, we talked about looking from the equations. So if I look at this equation and this equation, I can tell that they have the same slope, -1 and -1. But then I notice they also have the same y-intercept. So once I rearrange and get these equal to y, if I notice they have same slope and same y-intercept, it would be infinitely many solutions. So at this point, now that you've seen the notes, the back side of the worksheet is homework due Monday. If you don't finish it in class, I will be walking around to check it for points on Monday.